We have the Intermediate 2, Units 1, 2 and 3, Paper 2. It'll be great revision for National 5 if you're doing National 5, or if you just like to check out how you've done in the 2013 exam. Here it is. Question number 1, multiply out the brackets and collect like terms. So we've got x plus 2x minus 5, we multiply that out, I would call that FOIL. Then we subtract 9x. So the FOIL thing I just mentioned, you do the first bit in each bracket, the outside bit, the inside bit, the last bit, multiply them all together. Or some people like to call it the rainbow thing, or the moon thing. And then after that we subtract the 9x. So we have x times x is x squared, x times minus 5 minus 5x, 2 times x is 2x, 2 times minus 5 is minus 10. Then we have to subtract the 9x, don't forget to do that. Then how many x squared? Just got x squared. Minus 5 add 2 is minus 3. Take away another 9x, minus 12x, or negative 12x, and we've just got minus 10 on its own. So x squared minus 12x minus 10. Question number 2. Company buys some machinery worth £750,000. The value goes down by 20% per year. The machinery will be replaced at the end of the year in which its value falls below half of its original value. After how many years should the machinery be replaced? Right, if it falls by 20%, it will be worth 80% of what it was originally worth, or that's just 0.8. So after year 1, it's worth 0.8 of 750,000, which is 600,000. After year 2, it'll be worth 0.8 times the 600,000. That was the value after year 1, remember, which is 480. Year 3, 0.8 times the 480,000, 384,000. Now I've not mentioned it yet, but it was originally worth 750,000. I've kind of worked out in my head that half of that's 375,000. I probably should have written it down at the start, to be honest. Now, so not quite below that. So again, 0.8 times the, oh, it's the wrong number. A little bit of a working out error there. 0.8 times the 384,000 would be £307,200, which is below the 375,000. But like I said, I'd forgotten to write it at the start, so I've just added it in at the bottom there. So it would replace after year 4. Question number 3. A sample of voters were asked how they intended to vote at the next election. So there's the table. And construct a pie chart to illustrate this information. So what do we need to do a pie chart? Well, we know there are 360 degrees in a circle. 35% of those degrees will be taken up by the SMP. So 35%, I've got a calculator, let's use it. 35 divided by 100 times 360. So that'll be 126 degrees for SMP. Similar calculation for Labour, 30 divided by 100 times 360, so that'll be 108. And we also have Lib Dems 54, Conservatives 36, other 36. Then we draw a circle, get a protractor out, put that line in first, line up the target on the protractor there. I know it's 126 degrees, I know that's an obtuse angle, so once I've lined up the protractor properly, I'll be looking for the obtuse 126. Not the one that's going to give an acute angle, because there's always two values for every number between 0 and 180 on a protractor. So get the 126, then after that, line it up there, measure 108, line it up there, measure 54, line it up there, measure 36, line it up there. Should get the last 36 if you've done it properly. Question number 4. Triangle PQR is shown below. Calculate the size of angle QPR. So angle QPR, Q to P to R. So calculate this angle. There's 3 sides in the question, and we're finding out one angle. Have a look at the formula sheet. For the sine rule and the cosine rule, the one that includes 3 sides and 1 angle is the cosine rule. And I'm going to use the one that starts cos A because I'm working out the angle A. If it was little a, I'd be using that to work out the side, but I'm not working out a side here, I'm working out an angle. So rather than rewriting the formula in terms of cos P and little r, little q, I'm going to make life easy for myself. I'm just going to rename angle P to A, angle Q to B, angle R to C, which will make this little a, little b, little c. So then formula cos A is b squared at c squared minus a squared over 2bc. Again, it's on your formula sheet. Just substituting in. Got a value of a, b and c. Substitute in there and in the bottom. Use your calculator to do that. If you've got a Casio calculator, it's great because you can just type them all in one go. Does it for you. You can't actually make a mistake there. So we've got cos A. To find out A, we need to remove the cos. We do that by doing the inverse of cos, or shift cos, or second function cos on your calculator. So cos to the minus 1 of, keep this value, do not round this value here, keep that value on the screen of your calculator, otherwise you'll get a rounding error. So just keep it on your screen, shift cos, press equals, 30.6 degrees. And because I've renamed it A, but the question was asking for angle QPR, I'm just writing that down at the end. Question 5, solve this equation. Given the roots correct to 1 decimal place. The fact that the roots will be given to 1 decimal place means that you're going to have to use a quadratic formula. If we could just factorise it, put it into a pair of brackets, I wouldn't say to 1 decimal place. I would just say solve. The fact it's 1 decimal place means we're going to have to use the quadratic formula, which is this formula here. So, first of all, go back, write down with the value of A. A is how many x squared, B is how many x's, C is the number at the end. Don't forget the minus signs if they're there, otherwise it doesn't work. So, minus B, minus 5, plus or minus the square root of B squared minus 4AC. Substituting in the values, all over 2A. Notice here I've got minus 5 squared, minus 5 times minus 5 is 25. Minus 4 times 1 is minus 4, times that by minus 2 we get plus 8. So 25 plus 8, 33. Again, if you type into your calculator with the brackets on, you will not make a mistake. If you don't do that, some people do make a mistake, a lot more than you'd think. Too many people. So we've got 5 plus or minus the square root of 33 all over 2. Just remember this plus or minus means there's going to be 2 answers, there's going to be 2 solutions here. Either 5 plus root 33 over 2 or 5 minus root 33 over 2. So here we'll just type into the calculator, get the answer out, and the question, remember, said 1 decimal place. So it'll either be 5.3 or 5.4. The next number's a 7, so we'll round up to 5.4. Here, negative 0.372, again, the number after the 3 is a 7, so we're going to round up, so it'll be minus 0.4. Both to 1 decimal place as requested. Question number 6. A standard deviation question. It's talking about a golfer, but basically we have these 5 values, we need to find out the standard deviation. 2 different ways to do it, 2 different formulas given. First of all, find the mean, add them up, divide by how many numbers we've got. So the mean is called x bar at intermediate 2 level. Add them up, you get 410, divided by 5, we'll get 82. So I've seen 2 different ways to find the standard deviation. This is the way that I choose to do it with my classes. I'm sure half the teachers in Scotland do it a different way. But write down x, which are just the data values, the numbers from the question. We'll do x minus x bar, so the number take away the mean. Do that every time. Then we square those values, so 2 squared is 4, minus 4 squared again is positive 16. Minus 2 squared is positive 4, minus 1 squared is positive 1. we add them up. When we add them up, we get the sum of x minus x bar all squared. I should be writing that in. Now, why is that important? That's important because that's the top line of the standard deviation formula. So all of this here is just 50. So substitute in, so it's 50 over, it said n minus 1, n's how many numbers? There's 5 numbers, so 50 over 5 minus 1, which is 50 over 4. 50 divided by 4 is 12.5. The square root of 12.5 is 3.535, dot, 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 dot. Round up to 2 decimal places, 3.54. Right, part B. His partner for these games is Tony, whose scores are listed below. Right, just through experience and going over lots of these questions, I know there's probably a link between these and the previous ones. They're all exactly 20 more than the first value. So he's always taken 20 more shots. So his average score is going to go up by 20 shots. So the mean, 82 at 20, 102. Part B, the standard deviation, that is just how spread out the values are, because it's exactly the same score but added on by 20, increased by 20, that just is spread out. So if you like, we're going down by 6, up by 11, down by 7, up by 1, be exactly the same here, so the standard deviation does not change. Alternatively, for part B, you could have just done the same as part A and worked them all out all over again. You would have got your 2 marks. Number 7, a lead cube of side 10 centimeters is melted down. During this process, 8% of the metal is lost. The remaining metal is then made into a cone. Find the height of the cone, given that the radius is 8 centimeters. So cube, all the sides are the same. So volume's either length cubed or length times breadth times height. Again, the sides are all the same, so 10 times 10 times 10, which is 1,000. 8% loss, so there's 92% left. 92% of 1,000, 92 divided by 100 times 1,000 is 920. That is going to be made into a cone. Volume for a cone, 1/3 pi r squared h. What do we know about the cone? We know the volume, so I'm substituting a 920. We know the radius, so I'm substituting an 8. I know 1/3 is 1/3, I know what pi is, I know what 8 squared is. I'm just going to do this calculation here. So it'll be 67.02 dot 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 dot. So I've just put down the first 2 digits, dot dot dot, just showing that there's more digits there, times by the height. So to get the height on its own, be 920 divided by 67.02. Again, the reason why I'm not rounding, if I use the exact value that was on the screen, I will not make a rounding error. I should only ever round at the very, very, very end of a question. So the height will be 13.7 centimeters to 1 decimal place. That's the 920 over the 67.02. Number 8. Change the subject of a formula. We're trying to change it to b. So here I've got a equals 3b squared plus c. I am going to rearrange it just like I would do in an equation. I add or subtract first. I'm going to subtract c from both sides here. So it will be a minus c equals 3b squared. I am then going to divide through by 3. Divide both sides by 3, and that's what you get. And then I want b, but I've got b squared, so I'm going to square root both sides. So it'll be the square root of all of this is the square root of b squared, which is just b. So I get square root of that equals b, and because b is a subject, it should be on the left hand side. Just move across at the end. Question 9. Simplify this. X to the 6 over y squared times y cubed over x cubed. Here it is. So we're dividing powers, so we'll just subtract them. So x to the 6 minus 3 multiplied by y to the 3 minus 2. So that's just x cubed y, because y to the 1 is just y. Number 10. Number 10. We basically have this triangle. It's talking about the height of a tree, but it's basically saying how long is this bit. So in these types of questions, quite common in an Int 2 exam, it's going to be the sine rule, then either right angle trig, which is SOHCAHTOA, or the sine rule again. So at the moment, I know this is 38, this is 90, I can work out that angle there. After that, I'd be able to work out that angle there. So as I was saying, 180 minus 90 minus 38, that's 52. I'll draw that in. Then after that, 180 minus 52 is 128, so we've got 180 degrees on a straight line. So that leaves me with this top triangle looking like this. What I'm going to do here is calculate this side, and I've got that angle, that side, that angle, and I want that side, so it's two sides and two angles. It's going to be the sine rule. So 4 over sin 12 is ST over sin 128. Cross multiply to get ST on its own, then press the buttons on the calculator, 15.16. So that leaves me with looking at the big triangle. So I've removed the one that was coming up here. This is just the big triangle. Go back to the question. So I'm looking at all of this. So I'm ignoring this bit in here. The only bit that I'm using here is 38 at 12 is 50. So this bit now is 50. I've just written 38 at 12 there. So if we like trigonometry, if we like SOHCAHTOA, sin, cos and tan, that sort of thing, we could start labelling the sides. I just find most pupils like to use the sine rule again, so it would be 15.16 over sin 90 is side BT over sin 50. Try and work out BT, so cross multiply the sin 50, hit the buttons on the calculator, 11.61. So remember, that's not quite as finished because it just wanted this height here. We know this is 4. This whole thing here is 11.61. So 11.61 subtract 4, 7.61. Number 11. Fraction question. Write it as a single fraction in its simplest form. So two ways of doing this. We either go for move that up there next to the 3, that up there next to the 5, and put these two on the bottom together, or we say we have to multiply top and bottom here by x minus 1, top and bottom here by the denominator here, x plus 2. That's the way I've done it. The reason why I'm doing that is to get a common denominator. So on the bottom of both, I've got x minus 1, x plus 2. So I'm going to write it as one fraction. Then it said to simplify it, so in other words we can multiply out each bracket. So 3 times x minus 3 times 1, 5 times x plus 5 times 2. Collect the x terms together, 3x add 5x, minus 3 add 10, and we're still over the same common denominator. And that's that done. Question number 12. It's a circle, there's a line of symmetry, it's quite often Pythagoras. Can we see a right angled triangle? There's one there. So the points C and D are the centres, and each circle has a radius of 24 centimetres. AB is a common chord of length 30. So that bit there's 30, this bit here is 24. So I'm going to draw that diagram. Don't need the circle bit. So I've got 24, all of that's 30, so that bit there's 15. So remember, Pythagoras says short side squared add the other shorter side squared is the hypotenuse squared. So I'm going to have DE, which I'm working out. DE squared add 15 squared equals 24 squared. Get DE squared on its own, so take the 15, subtract 15 squared from both sides. Or move it across and make it minus, if that's the way you like to think about it. let the calculator do 24 squared minus 15 squared. Remember that's DE squared, so we need to square root here. Find DE. That'll be 18.7349 ... Back to the question. We have worked out that bit there. We also have that bit there, which is the same. We also have the radius, which is 24, the radius there, which is 24. So it'll be twice what DE is, plus twice the radius, which comes out as 84.4699 ... which is 85.5 to one decimal place. Number 13, I get this done before the battery runs out on the phone. It's basically a trig equation question. It's asking when, this is the equation that tells you the height of where the big wheel is. Find 2 times during the first turn when the car is at a height of 10.8 meters. So we have the equation. We substitute in 10.8 for the height because it tells us that's the height in the question. Subtract 7 from both sides. Divide through by 5 because we're trying to get sin t on its own. So divide both sides by 5 here. After that, we've got sin t equals something. So I've just rearranged it to get the t on this side, and we'll have to do sin to the minus 1 just to get the sin away from the t. So that shifts in on the calculator of bracket 3.8 divided by 5, tells us it's 49.5, but the question said 2 solutions, or 2 times. It's basically telling us it's one of the ASTC diagram questions, so we're ticking A for all and S for sin because it's a sin question, and also this is a positive value, so we'll tick the A and the S. If it was negative, we'll tick those 2. Just remember this quadrant here is 180 minus the angle, this quadrant here is just the angle. It'll be 49.5 and 180 minus 49.5. So it's 49.5 and 130.5 degrees. And that is paper 2.